In the previous lesson, we learned about the conversion factor mole ratios and how we determine the mole ratios based on the chemical formula or a chemical equation where the chemical equation is balance. And for a chemical formula, we focus on the subscript, where in a chemical equation, we focus on the coefficient. And the beauty behind the mole ratio is that we can now convert from one chemical, which is represented by A, to another chemical represented by the letter B. So let's see how is that going to work in our problem. We have a chemical equation below describes a chemical reaction between iron and oxygen gas that produces energy, which we know is in joules or kilojoules, and a new substance called iron 3 oxide, which is right here. So here, this is a chemical equation that describes the chemical reaction. And we have 4 moles of iron react with 3 moles of oxygen gas to produce 2 moles of iron 3 oxide. The question asks how many moles of oxygen gas, which is O2 right here, are needed to react with an excess amount. The word excess, I mean you have a lot of it. You have an endless amount of it, of iron to produce 5 moles of iron 3 oxide, or Fe2O3. So we look at this problem, we have to realize our given is basically the one that has a unit and a number to it, which is 5.0 moles of iron oxide. So this is our given. So our given is 5 moles of iron oxide. Okay. And our unknown is basically asking for how many moles of oxygen gas. This would be our unknown. So again, our unknown is moles of oxygen gas. So let's go back to our flowchart again. We always start, look at the box. We always look at the box, that's where we start. And the arrows are the conversion factor that we need to multiply to get to a different box. Our starting will be at the given unit, and our ending will be the unknown unit. In this case, our given is moles of Fe2O3, which is on side A. We always start on side A. And in this case, our chemical change to oxygen. So our unknown is going to be moles of B, which is A right here, that's where we start, and B is where we end. So what is the conversion factor? It's mole ratio. So we multiply that by that mole ratio. And how do we determine that mole ratio? In this case, the mole ratio between Fe2O3, which is right here, and oxygen, which is right there. And we know that it is 2 mole of Fe2O3 equal to 3 moles of oxygen gas. And we go back and look at this one. If this is mole of Fe2O3, this bottom part must be moles of Fe2O3 to cancel it out, the same way you did before. The top part would be the leftover of the conversion factor, which is 3 moles of O2. And that's all we have to do. Notice how we get moles of O2 as our unknown, and we cancel out the moles of Fe2O3 and give us 5.0 times 3 mole of O2 divided by the number on the bottom, which is 2. And that is our answer. Let's try another problem. So the description of this reaction is still the same, but I changed the problem. How many moles of iron are needed to react with 3.5 moles of oxygen gas to produce Fe2O3 or iron 3 oxide? So again, our given is the one that has the values as well as the unit and the chemical, which is given to us 3.5 moles of oxygen gas. This is our given. And we are looking for how many moles of iron. So let's plug into the formula. Our given is 3.5 moles of O2. And our unknown is moles of Fe. Again, we always start from our given unit, which is moles of A. We always start at A. Since our chemicals are different and we still have the unit mole, we must go in from mole A to mole B. So this is where we start and this is where we end. Again, we go through the mole ratio conversion factor. And what is the mole ratio conversion factor? In this case, it's a chemical equation, so we focus on the coefficient. So we have the mole ratio between oxygen and Fe. So we have 3 moles of oxygen gas equal to 4 moles of Fe. And we take a given and multiply by this conversion factor. Since this is moles of O2, the bottom part must be moles of O2 as well. And the top part is the leftover part, which is 4 moles of Fe. And we are done because this is our unknown. So we cancel out the unit, moles of O2 cancel out. Once we cancel the unit, we multiply everything on top, divide everything on bottom. So 3.5 times 4 moles of Fe divided by 3. And this is our answer. Let's try another problem. Again, the description for the reaction is still the same, but I changed the question around. How much energy in kilojoules are produced from reacting 1.5 moles of oxygen gas and an excess amount of Fe? So we can look this as, so we know right away, our given is 1.5 moles of oxygen gas. This is our given, and we're looking for how much energy in kilojoule. So again, let's go back to our ideas of conversion factors. So our given is 1.5 moles of oxygen gas. So our given is 1.5 moles of oxygen gas. And we are looking for energy in kilojoule. And if we look back at the previous lesson, we can think of energy as a new substance that can be represent itself as a unit in terms of mole. So here we have energy, and that energy is directly related to other chemical in unit mole. For instance, in this case we have oxygen right here. So we can say the conversion factor between oxygen and energy is 3 moles of oxygen equal to the energy in kilojoule. So this is our conversion factor that we can use, and the way it works is this. Notice how we have moles of oxygen, so the moles of oxygen will be on the bottom and the energy part will be on top. And we see that moles of oxygen is being cancelled out, give us our unit in kilojoule, which is the energy. So again, multiply everything on top, divide everything on bottom. And what we have at the end is 1.5 times 1652 kilojoule divided by 3. We basically multiply everything on top, divide everything on the bottom. And this is our answer. Let's try another problem with energy. Again, the description of this chemical reaction is the same. In this case, the question is here. When 1.7 moles of iron react with an excess amount of oxygen gas, that means we just ignore it, okay? To produce iron 3 oxide, which is Fe2O3. It will also produce how much energy? So notice how our given is 1.7 moles of Fe, and our unknown is energy. So we can plug back into our formula here. Our given again, 1.7 moles of Fe, and our unknown is question mark kilojoule, which is a unit of energy. And of course we always start from the given, which is moles of A right here. And we are looking for energy, but energy is not on the flowchart. But based on our previous lesson, we can relate energy to mole using the chemical equation. In this case, we have energy and moles of Fe. So our conversion factor is this. We have 4 moles of Fe equal to 1652 kilojoule. Once we have a conversion factor, we multiply by our given. So in this case, we have moles of Fe, so the moles of Fe will be on the bottom. And the top part would be the energy. And mole cancel out. We multiply everything on top, divide everything on the bottom. Give us 1.7 times 1652 kilojoule divided by 4. And this is our answer.